Cool. So what I want to say to you at the start of class today is I want to finish up lesson 6. I sent an email out to the class yesterday morning. If you haven't checked your email yet, I suggest you do check your email and look at that. I had quite a number of people run into some technical difficulties with their section 1.5 online homework. And because I had such a high volume of emails with the same comments, I did extend the 1.5 online homework in case anybody needs it through the weekend. My hope is that you got it done prior to the test, but you know, if not, you do have a bit more time to complete that, because when there's technical difficulties, you know, that's not your fault. So anyhow, that's number one. Again, I hope to finish lesson 6 today. And I also have tests to hand back today. I did enter the test grades in Moodle. I don't know if you've noticed them or not. I entered them yesterday evening when I finished all the grading and totaling up and everything. There was no curve put on the test because the high score was a perfect score. And even aside from that, there were a bunch of 99s on the test. So that was pretty cool. I want to tell you that my grading scale for this course is 90 and above is an A, 80 and above is a B, 65 is the low C, and 55 is the low D. Okay, so if you get a 65 on the test, you got a C. Okay, there's no wiggle room on that. What I want to say is, if you were on the border, I mean, you know, suppose you got a 63 on the test, don't freak out. My goodness gracious, if you're 2 points away from the next grade at the end of the semester, you're going to be bumped up, right? There's always like a little buffer. And, you know, it usually doesn't come down to that. But what I want to say is, if you're at the border of any of these points, don't stress over a few points, because at the end of the semester, I assure you, it won't really make much of a difference. Okay. Other quick comments that I want to make in terms of the test is, number one, if you want it back, you need to come to class at some point or come to my office. We can schedule a time to meet at my office for you to get it. I want you to come and pick it up at some point. I mean, those of you who are in the room with me here, like, you're going to get it, right? But I'm speaking more toward the people on Zoom and the people who will be accessing this recording later on. You want to get the test back. I will be posting the solutions to the test to the class Moodle page. And what I think is very important, you know, is for you to look at what you got wrong and try to figure out like what happened in there. If you need to come and talk to me, my goodness, I am so available to set up an appointment with you, either live or on Zoom. It can be day, evening, weekend, you know. I don't ever really have many plans. So other than working all the time. So you know, please feel free to come and talk to me about that. The other thing that I'm going to say is, if you didn't do as well as you wanted to on this test, don't beat yourself up. Okay. You know, I was a student for a long time, you know, going through undergrad, going through graduate school, all of that. I will tell you 100%, no one test is going to significantly impact your grade. Okay. I've designed the course and I've structured the course and, you know, distributed the percentages about how much everything is worth, so that there is not that intense pressure. Okay. The first test in a math class can be extremely intimidating, right? You don't know what to expect. You've never had me as a teacher before. You don't know necessarily how I'm going to word things, et cetera, et cetera. So the first test is also quite the learning experience in terms of just kind of getting yourself settled into a course. So if you didn't do as well as you wanted to on the test, I will tell you at the end of the semester, it looks a lot better if you start out down here and improve rather than starting up here and tanking, right, as the semester progresses. But I just want to assure you all that, you know, whether I'm teaching a class of 10 or a class of 400, I look at the end of the semester at each of you individually, and I look at trends. I look at, well, how were the tests versus how were the class activities versus how was the online homework, all of that sort of thing. Okay. It's why I take a long time to determine final grades, but I feel like it's only fair to consider each of you as individuals and look at things like that. So I just want to assure you that, you know, again, no one test is really going to impact you. I will say that if you did not pass the test, you might want to think about coming and talking to me. Like if you got below a 50 on this test, I would strongly suggest that you come and talk to me so that we can figure out ways for you to improve your success as the course continues. Okay. Any questions? Was the test about what you expected? Harder, easier, longer, shorter? I mean, feel free to express your opinions. Lord knows I never held back when I was asked to express my opinion. And if you're not comfortable talking about it out loud here, I totally understand, but I want you to feel free to like talk to me about it. Is what working? Haley, I saw your chat. I'm wondering, you asked, is it working? I'm wondering, is what working? All right. Huh. The rest of you on Zoom, can you see and hear me? Can somebody unmute? Okay, yes, thanks. Okay, okay. I appreciate you responding. Haley, I guess it does me no good to say this because if you can't see or hear me, let me just type to her. Okay. All right. So how about we talk about some math for a little bit, and then I'll hand the test back at the end of class. Sound okay? Okay. But I do want to say, if you got a 65 or above on the test, I consider that a true success. You know, you might feel like, oh, I should have done better. You've got the rest of the semester to improve. Honestly, you know, that is a solid score. And so please don't beat yourself up over these things. Okay. And if you want to come and talk to me about ways you can improve studying, or if you want to come in and meet with me, you know, every few sections so that we can work together to make sure that you're on, I'm totally present for you. You just have to send me an email saying, giving me your schedule when you're available to meet, and I'm happy to meet with you. Okay. Okay. Everyone's so quiet today. No one has anything exciting to say and to chime out? Okay, well, then I'll just keep rambling. So we were talking about our tree diagrams yesterday. Oh, and if we finish 1.6, let me, or 1.6, sorry, I was thinking about my algebra class. If we finish lesson 6 today, I do want to give you hints on the homework that will help you proceed through the homework. You know, on my tests, you don't have to guess, should I draw a Venn diagram? Should I draw a tree diagram? I'll always tell you to do that. The homework, they don't guide you in quite the same way. So I want to be sure that I do in order to provide direction. Cool? Okay. So what I want to talk about right now are independent events. This is not a huge thing in this section or in this class. If anyone's going on and taking Stat 216 next year or next semester, you will be talking about independence more in that class. But we just briefly touch on it here in the Math 115. Okay. So when we're talking about independent events, again, you don't have to memorize any definitions or anything like that. We're going to develop some formulas and the like, but essentially, one positive is that when we talk about independent events, what it means is pretty intuitive. Checking it is not necessarily extremely intuitive, but I'll show you exactly how to do that. But we say that two events are independent if the outcome of one has no influence on the outcome of the other. Would you agree that that's a pretty intuitive definition, right? They're just independent, have no relation with each other. Okay, so we can now start honing in and say, well, maybe how about events A and B are independent if the probability, say, of B is the same whether or not A happens. Do you see that as a natural follow-up? Yeah. Thank you. I appreciate it. All right, well, I'm going to start throwing in some notation here then. What I'm saying here then is the probability of event B, given that A happens, is the same as the probability of B. Like, who cares whether A happens? This is true if they're independent. Does that make sense? And if these events are independent, then the probability of A, given that B happens, is just going to be the probability of A. Who cares whether or not B happens? They're independent. Now, what I'm about to show you is the motivation of where this independence formula comes from. You're not responsible for doing this, for deriving this formula in this class, but I want to show you where it comes from, because otherwise it just seems so arbitrary. Okay. So we had the definition of conditional probability, and I'll just do probability of B given that A happened. This was part of our definition of conditional probability, right? If we want to find the probability of B given that A happened, well, we're assuming A happened. So remember, what we do in practice is we reduce our sample space down to A. And then we say, okay, with this reduced sample space, with A, when does B also happen? Okay, don't get anxious about this formula. Okay, let me ask you this. Can I rewrite this formula without a denominator? How do you get rid of denominators in math? You multiply both sides by it. Okay. If I multiply both sides by it, do you agree? Then on my left, I have the probability of A times the probability of B given A. And on my right, they cancel. All right. Well, if these events are independent, isn't the probability of B given that A happened the same as just the probability of B? So we have probability of A times probability of B, and I'm just going to write those in alphabetical order, is equal to the probability of the intersection. Okay, this is the same, this is the same. And what we're saying is if these events are independent, then who cares whether or not A happened? It's just the probability of B. Well, that gives us our formula. Okay, so this is all to say, and this is what you're going to want on your little cheat sheet, you know, to have when you're doing your homework and your test, is as follows. The way mathematically we check independence, we say events A and B are independent if and only if, and I'll explain what that means. The probability of A intersect B is the probability of A times the probability of B. And I claim that's exactly what I just rewrote this that we had on the previous sheet. Okay. So what this says is when you have if and only if, it means the implication goes both ways. If A and B are independent, then we know this to be true. On the other hand, if we know this to be true, then we can say that A and B are independent. Okay. Now, one hint that I'm going to give you is when checking independence, the union rule often appears. And remember, the union rule says the probability of A union B is the probability of A plus the probability of B minus the probability of the intersection. So it's good to keep in mind when you're dealing with independence that you may need to use the union rule. Now, is this a huge thing in this class? No, it might be like a 4 or 5 point question on your next test. That's about it. But I think that this can be helpful for us to go through for a bit. Yes.
So we've been working previously with most independent events.
Many events are dependent, but not all of them. You know, like, so for example, when you pick a jelly bean out of a jar and then you put it back and you pick another jelly bean out, those are independent events. presumably if you have a fair coin, when you keep flipping a coin repeatedly, those are independent events. But for example, if you picked a jelly bean out of a jar, noted the color and ate it, so you didn't put it back, then the probability that the next jelly bean is a particular color, that's a dependent event.
Is that where the trees come in?
That is where trees come in. Yes. So what I want to do is just take a few examples and play with this. Okay. And I'm going to show you every sort of example that you're going to be seeing. Suppose I tell you that the probability of A is 0.25. And I tell you that the probability of B is 0.2. And I tell you A and B are independent. Okay, this is what is given to you. What we want to do is we want to find the probability of A intersect B as well as the probability of A union B. All right. Well, again, you need to assess what you're given. We're given the probability of A, we're given the probability of B, but we're also given that they're independent. So, knee-jerk reaction. When you are told that two events are independent, you know this is true. Since they're independent, I know that the probability of A intersect B is the probability of A times the probability of B, right? We're given that they're independent, therefore we know this to be true. Well, I claim this gives us a way to find at least one of the two things, right? What can we find straight from here? The intersection, because what's the probability of A? 0.25. What's the probability of B? 0.2. So doesn't that give us the probability of the intersection? If you multiply those, you get 0.05. You with me there? Can I get the probability of the union now? Yes, what can we use? The union rule, right? We can get the probability of the union because now we have this, this, and this. So I can say, well, the probability of A union B is the probability of A plus the probability of B minus the probability of the intersection. What's the probability of A? 0.25. What's the probability of B? 0.2. And we got the probability of the intersection is 0.05. So we get 0.4. So in this first example, notice we were given that they were independent. So we knew this equality to hold. You with me there? Now I'm going to give you another example, but now I'm going to ask you if two events are independent. Okay. So suppose I tell you that the probability of E is 0.24 and the probability of F is 0.45. And I'll also give you that the probability of the union is 0.582. And what I want to know here is, are events E and F independent? All right. Well, How do we check whether or not two events are independent? How do we check independence? What's the formula? We check independence by saying, well, is the probability of E times the probability of F equal to the probability of the intersection? Do you all agree that this is what we need to check for independence? Well, do we know the probability of E? Yeah, what is it? 0.24. Do we know the probability of F? Yeah, it's 0.45. Do we know the probability of the intersection? Not yet. So we know we can multiply these and we could get 0.108 if we multiply that. But we don't know the probability of the intersection. However, we are given one other piece of information that we have not yet used. We can use our union rule to find that. We can say, well, the probability of E union F is the probability of E plus the probability of F minus the probability of the intersection. Do we know the probability of the union? Yep, what is that? 0.582. We know the probability of E is 0.24. The probability of F is 0.45. And this is our great unknown. Well, we have 0.582. We can certainly add 0.24 and 0.45. We get 0.69. And then I'm just going to call that X because I like calling my unknowns X. Can we solve for X? Yeah. Okay. Now, to me, the fastest way is just take 0.69 minus 0.582. But if you want to solve this algebraically, you would say, well, if we want to get X alone, you subtract 0.69 from both sides. 0.582 minus 0.69 is negative 0.108. And that's equal to negative X. But we don't want negative X, we want positive X. How do you make it positive? Yeah, you multiply or divide by a -1, and you get X to be 0.108. So we can answer our question now. Are these independent? Well, we got the probability of E times the probability of F to be 0.108. Didn't we get the probability of the intersection to be the same thing? So we say, yes, they are independent. And I very carefully crafted these numbers so that they would be. Yes. Yep. If you have equality, they are independent. Now, I know this looks like a lot of stupid, like formula computations. When am I ever going to use this? So what I'm going to do is just do one more example today. And I'll use words. And then I want to just show you some things in the lesson 6 online homework. So suppose the probability that somebody likes to draw is 0.36. And I'm going to call that D for draw. And how about the probability that someone likes to sing, and I'll call sing S, is 0.15. And further, suppose D and S are independent. What if I want you to find the probability that a person likes to do at least one of these activities? Well, this involves a bit of translation, doesn't it? Okay, so knowing that we're using independence and we have intersections and unions, what am I wanting to find using those notations in terms of D and S? What is at least one? Doesn't that mean that somebody likes to draw or sing or both? Would you grant me that with the translation? So when you say draw or sing or both, what set operation are we doing? Union, right? Intersection means draw and sing, right? The union is one or the other or both. So what we're really wanting to do here is find the probability of D union S. You with me there? This is why I keep focusing on all these keywords. Well, can we find that? One hopes, right? We know the probability of drawing is 0.36. We know the probability of singing is 0.15. If I want to find the union, presumably that tells me that I'm going to use the union rule. But notice we're given one other piece of information. What are we given? We're given that they're independent. So since they're independent, don't we know that the probability of D intersect S is the probability of D times the probability of S? So we got 0.36 times 0.15. If you multiply those together, you get 0.054. So the added information that these are independent gave us the probability of the intersection. So now we can go to town. Probability of D union S is the probability of D plus the probability of S minus the probability of the intersection. So we have what? 0.36 plus 0.15 minus 0.054. And that's what we got. So for the most part, we've really completed this section. I want to do something really quick on your MyOpenMath. Huh? Cool. Whoa. Share screen. Okay, so lesson 6. What I want to do is I'm going to assign the homework to be due a week from today. But before I do that, I just want to take you through some of this so that you know how to answer these questions. This is a huge hint, so take this, okay? So number one, it goes back to the table problems that we do with conditional probability. So, find the probability that a student got a C, given that they're a female. Remember, what we do is we reduce our sample space down to the females. In other words, our denominator is what? 17. And from just this row, how many got C's? 6. Okay, so this goes back. Huh? Oh, so this goes back to the table question. Here they give you a hint to draw a Venn diagram. Here they give you a hint to draw a Venn diagram. Yeah. When you're talking about not B and not A, you cover up your circle B, and then it's those other 2 regions. No, everyone should be thanking you for asking that question. Thank you, Jackson. Okay. You can draw a Venn diagram here if you'd like. This is independence. This is another table. But what I want to say is questions 7, 8, and 9, you got to draw a tree. That's my big hint. Okay. So for the online homework in lesson 6, for numbers 2 and 3, you want to draw a Venn diagram. And for numbers 7 through 9, draw a tree. And I'm going to give you a hint on this tree diagram. It's all assuming the outer branch, find the probability of the inner branch. Okay. Now I'm happy to start class on Monday with going through one more tree diagram, if that would be helpful. You can all let me know that on Monday morning when we see each other. Cool. All right, so those of you who are on Zoom, I'm gonna tune out. At this point, I'm just gonna hand back tests. You can find your test score in Moodle, and I hope you have an awesome weekend.